Hi everyone, my name is Sol. I'm a product manager working on Dynamo. Call myself a curious human being and also based out of Boston, Massachusetts.
All right, so before we begin, we've got...
yeah, we put the slide in the wrong place. Apologize for that. All right, well, you can enable live transcriptions in 11 languages by clicking the more options in Zoom and turn on the live captions. You can interact and participate using Zoom reactions or just try and annoy Jacob. I think that's probably a good thing to do. Just anytime he says something deadpan serious, do laughing. That would be good.
That's my move.
You can raise your hand and we can enable your audio if you need to ask a question. You can use the chat for general comments and converse, or you can use the Q&A module to ask questions in there. We can track those questions as they're asked and answered. It's up to you. There's no hard rule there. The session is recorded and the recording will be posted on the community conversation event page. So there we go. We're back to the good stuff.
Alrighty, welcome everyone. Thank you for joining us for our first session in 2023 of the Dynamo Office Hours series, which is session number 40. So we, to date, have 39 hours of awesome content previous to this one. This will be the 40th, and this is around getting all starry-eyed in Dynamo. So this is a little sort of composite session of the one that Jacob gave at AU, talking about how to make some funky geometry, in this case stairs, and pushing that into Revit. So like usual, we have an agenda of roughly a 20-minute presentation on getting all starry-eyed. We have a live demonstration, which Jacob's going to show you how to do it all. And then we have a Q&A at the end. But please, as this is a conversation, do ask your questions throughout. We're more than happy to break. We like interruptions. We welcome it. Please come and ask us all the hard questions.
All right, so without further ado, let's get started. So this session actually dates back to early spring of 2022 when I got a message from Sol, who was actually doing his AU sort of presentation ideas so that he could submit what he wanted to present on. And then one of them really stuck out, and that is this session, and actually got approved. So he had this idea of sort of showing how we might model this really complex thing. Which, by the way, is a great session idea for anybody who's thinking of submitting something for next year. Just maybe don't do stairs. We kind of already covered that. Now, the problem with that idea is all of AEC is super complex. If you study any part of it long enough, you realize that there's a whole bunch of rules underlying that makes sort of Dynamo-generated geometry really, really tough to do. There's literally a session on any one part of the design process, as I mentioned before. So we had to sort of figure out what we wanted to do. And so we had a Zoom call and started to talk about different parts of architecture. And it winds up that cities are super complex. The construction of buildings is complex. The envelopes which keep us cool and warm are complex, right? The way we move around in buildings is complex. And this is about this slide was when Sol said, hey, what about that? My reaction was, well, that's a stair. And he said, yeah, what about that? And I said, but everyone hates stairs. And he said, yeah, what about that? And that sort of led to the stair kind of being the focal point. So Sol then went off.
Yeah, so we had this idea of modeling the stair in Dynamo. And as we know, and as Jacob just said, stairs are complex. They can be fun or they can be frustrating. They have lots of rules, like mostly mathematically driven. And decisions are really nuanced. They're really cleanly made. Like every stair essentially is unique unless you're building cookie cutter buildings. And even more fun, Jacob actually hates stairs. So it's a good topic to dive into because he's fallen on them a lot. There is an office culture in his practice days where stairs are hard. Let's have Jacob do it. But they look good. So we're just going to try and change Jacob's mind around stairs through this session.
That's when I responded. Yes. Yeah, I said, fine, but it's going to have to be a really cool stair.
All right, so I had previously, through my browsing of the internet, as one does, come across this rendering of a stair by Jorge Luis Velez Quintana. And we thought this was a really awesome thing to try and replicate inside of Dynamo to then push into Revit to have as an actual functional stair that comes through in a way that is not necessarily common to the Revit experience. And these are 3 different images or renders of the stair itself. You'll notice that it is quite complex, that there is mathematical relationships between all of the components here. And what we're going to do is essentially dissect the intent of how to get through constructing the stair today, then go and construct it and push it into Revit in all its glory.
All right, so the good news is we now have a stair that we want to sort of figure out how to model in Dynamo. That means we need to start sort of dissecting the intent. What does it look like? And there are a lot of complex parts here, so it helps to really break stuff down. Now, anytime that I have to sort of think about stuff like this, I open up Sketchbook on my iPad. It's always that close to me, if not already in my hand, and I start to sketch out what that extent is, or what that sort of math might look like. You've probably heard me talk about this before. I've got Sketchbook out for all sorts of different stuff that anytime I have to build anything complex. So what follows is a bunch of images from my actual sketchbook. You can see kind of off on the side here, the gray, that's actually the gray outside of my canvas in Sketchbook, and that's where all this stuff comes from. So first part, we've got 2 sets of treads built up in kind of a circular array. They've got a profile somewhat like that. Right? There's also a portal in the middle that kind of allows passage to the inner stairway, because we've got a stair inside a stair, stairception, if you will. And the exterior stair itself is bound by itself and the adjacent interior stair. The interior stair, meanwhile, is bound by itself and some kind of guardrail that's sort of happening on the side there, right? So it's got kind of that centralized post that's acting as guard at the lower levels anyways. We'll talk a bit more about that.
All right, so moving on, reviewing the treads. So the treads themselves are structurally forming the guardrails, as Jacob mentioned, the tread itself, and also the structure to hold them up. It sort of becomes one single object that gets translated and replicated around to form the entirety of the bulk of the structure. It folds down at the inside where the tread becomes a wall, and then it folds up at the outside where the tread becomes a guardrail. So what we want to do is review this radial structure to understand the relationship between the interior stair and the exterior stair. You can see, 2 people could be walking up the stairs, staring at each other on the stairs, getting a little starry-eyed on the stairs. The portal frame acts as the supporting structure for the treads above, and the tread edges themselves are beveled. But there are no handrails. So we need to consider this life safety sort of consideration. So the wrap up of the tread itself becomes a pseudo handrail in this case, and that makes sure that people don't fall off the stairs, which could be dangerous. And we're working with roughly a 4-foot diameter sphere for the overall stair itself.
All right, so with all of that done, now that we understand what's going on in the stair, we get to start mapping it to Dynamo. Right off the bat, radial forms are easily formed, and air quotes on that, easily as revolves. Now, helps to understand what we need to make a revolve. We covered geometry about 2 years ago in the Dynamo Office Hours series, so we might need a bit of a refresher. Revolves really need a few different things. They need a profile. That's the design element. We're going to come back to this in a minute. They need an axis origin. Might as well use the internal origin. So we can work with that. We need an axis direction, so the treads need to be level, so kind of on that z-axis in all cases. We need a starting angle. This is going to vary by each individual tread, and we need a sweep angle. It's going to be consistent on the stair for every tread. It's going to have the same sweep based on the total number of treads and the fact that we want to go all the way around in a complete circle. So with axis origin, there you go.
Moving on, we need to start talking about the next design element, really, which is the profile. So Jacob, I think you're flicking through a couple of slides here. So if we move into the actual profile itself, you'll notice that we start with the sketch of a tread. And this could really be conceptualized a bit as a polycurve. I think you need to flick through a few seconds here, please. It's kind of like a thickened polycurve. You can consider this as straight lines with a filleted operation that occurs or linear lines with a filleted operation that occurs at the corners. And onwards, please. These can be broken down to be defined by points to generate the actual location of these lines themselves. Then again, you can understand the dimensions from an origin point to understand relationships between all of these points. So again, Jacob sketches on the right-hand side. And then these dimensions can be converted to doubles or numbers, which you can use to mathematically drive this profile operation inside of Dynamo.
Advance.
Yeah. So again, yes, doubles can define the profile itself. So let's get a little bit deeper into these profiles. So we understand that, okay, this profile itself is going to generate the bulk of the stair operation in conjunction with the revolve that Jacob showed. We need to have the top of a railing fold, a landing fold, and a base point. And they're going to be mathematically driven to understand that there's a starting point and everything else has vectors or directions and distances associated with the locations of these other points. We can then define this base profile sketch that we can be used to generate the stairs through filleting operations and thickening operations as well. And again, there's a little bit of math here. We could probably pause here for a hot second so people can look at it or review the recording if they want to. But in essence, we're starting to talk a little bit more about the details of how you would actually go about constructing the relationship of this profile to then be used in the revolve and sweep.
All right, so that takes care of our profile design element. Now it's time to look at our sweep angle. Now, again, this is going to be consistent on the stair based on the number of treads. Now, you may have heard that there will be no math. That used to be a very good friend and coworker of mine used to say that all the time. I was told there would be no math. That meant it became a Jacob problem. I did the math for you guys, 360 degrees in a circle. So we must progress a total of 360 degrees. I've got n treads required to go from floor to floor. Each riser can only be m units. So we take our floor to floor, divide by m. That gets our riser count n. Number of tread count is equal to our riser count. And then we can start sort of incorporating a tread at the top of the stair to make sure that we've got kind of a clean transition in our landing. And then our degrees per tread is going to be 360 degrees in the circle divided by our tread count. All right. That takes care of sweep angle. Onto the starting angle, Sol.
All right, starting angle.
Oh, wait, no, this was one of mine. Never mind. We had the wrong piece, wrong name on there. All right, so to define the start angle, once again, each tread wants to start at the angle which the previous tread stopped, right? So our initial tread's going to start at 0 degrees. Final tread needs to reach 360 degrees. Each tread is d degrees. So in design script, we can kind of go from 0, ... 360, ... d. Start at 0, end at 360, step d degrees with a quick line of design script. And that takes care of the starting angle. With that, our tread revolves can now be made. We still have some pieces outstanding. We've got our eased edges. That's going to be the next step. The portal opening and frame, sort of edit the treads that have to come down and not pass through that portal to the inner staircase. And a whole bunch more, right? The nosing overhangs on the individual treads that you can sort of see happening right here. Materiality, elliptical fillet at the guardrail, internal structure and sort of construction layers. Lots more going on to this, but we're going to stop at this point just in the interest of time. We had, I think, 90 minutes in the AU session. We've got a lot less than that here, so we're going to be cutting it a little short.
20 minutes, let's go. Okay, cool. So mapping to Dynamo, so Jacob mentioned sort of eased edges. So you notice the rounding on the edges of the geometry itself. In Dynamo, you can do that using the solid fillet mode, which is awesome, and would totally suggest you play with it and check it out. It's not used as much as it could be, but is very, very useful to achieve awesome geometrical operations when you do use it. In order to use this mode, you need to understand which pieces of the sort of solid topographical piece of geometry you have, which you're trying to actually fillet. Because if you fillet everything by default, a cuboid can basically turn into a sphere, and that's not what we want in this case. So what you need to do is understand topology and get the correct faces. So to get the correct faces from here, we can do a little bit of filtering. After we get all those faces, we can filter them without anything, with a vertex elevation equal to 0. We can find those footing edges, getting all the edges, and then setting the difference of those edges. Sounds like a lot of words, it is, but in essence, you're simply doing some mathematical filtering to get the correct edges on the top of the revolve piece of that profile that we were looking for. So these tread revolves can actually be made easily with those fillet operations. And again, there's some more outstanding elements that we're not going to cover today around the portal. Oh, actually, we are covering the portal opening and frame, and then all of the nosing, materials, elliptical fillets, and so on that Jacob mentioned just before, we're not going to get into. So portal frame. If we want to create the portal frame, we essentially are creating a void or a cut through some of the structure. It needs to be structurally sound to be able to bear the weight of all of the structure above and the people walking up and down those stairs. It also modifies those treads by changing the actual geometrical outlook of them. And it again is another polycurve offset operation and a cutting operation. So the plan in a nutshell is defining the points of this cutting operation, essentially bound by the centroid, and then using fractions of the stair width, we can define a polycurve, fillet that polycurve, again, offset that polycurve, extrude it into a three-dimensional shape, and generate a void form by cutting this shape from the origin geometry. And then we also have to cut the interior of that piece out to create the void from which you can walk through as a human being and enter the center there.
All right, a lot going on there, but I think it'll start to make a bit more sense when we actually get into Dynamo. So the left outstanding is just the always more, the nosing, overhangs, etc. Now, we don't have time to cover all that stuff as noted before, but there it is. Now, there's one last step. Once we get everything sort of built in Dynamo, we want to be able to push it over into Revit. For that, I use the family instance by geometry node from the Springs package. It's an extremely useful node, absolutely worth getting used to. Now, there are some Revit API changes which have created some issues of late for people working in units other than feet. Sorry about this. Revit team made that change, and there's not really kind of a great way for us to fix it other than scaling your geometry to be in feet, not millimeters, not meters, not inches, but feet, prior to passing it into the node. So you just add a geometry scale node right before that geometry node, and you should be all set. So that brings us to the detailed map. So this is everything that we've kind of got to do. We've got to define our profile point sets, build our profiles, create our revolves, generate the eased edges, test for code compliance to make sure that it's code compliant, to make sure we can't fit the 4-inch sphere between there, so some poor kid doesn't come and get his head stuck between two treads or a guardrail or something. Once we've got code compliance set and confirm that, we're going to take those edged edges, subtract the void form from the treads. We're doing that from the set inputs to create the portal profile point set, creating our portal void, which becomes the piece we subtract from the treads, create our portal profile by doing the little donut extrusion, taking our portal extent and trimming it to the portal extrusion, the donut, gather all our treads in our panel, preview the results, make sure it's what we want, and then engage the create Revit mode to generate our family instances. Lots going on there. Now, conveniently, all of this stuff can really be broken down into one sort of simple set, right? So instead of having to go through and do a whole bunch of stuff and have one massive graph with all of these steps and all of these nodes in it, we're able to basically put together some custom nodes. We've got generate treads and generate portal and modify treads as two custom nodes that have been released in a package that I will show during the live demo, which starts now. Let's cue that danger music. All right, so tabbing over to Revit, I've already got a file open. It's a basic 3D file. Basic file. I am working in feet as noted before. And then when I look at the generic models, I've got nothing in here, right? Just an empty generic model family, which has no geometry, nothing up my sleeves as I start to perform this magic. And then I'm going to go ahead and I'm going to open the generate staircase node. And I've got a pop-up window that popped up underneath my Zoom windows. Gotta love that. I'm going to go ahead and hit accept on that and let this open up. All right, so here is the overall graph. I'm going to make sure this data gate is closed. And now we can start to have a look at this. I'm going to make this nice and big before I hit run. And we can start to sort of look at stuff. We've got our initial variable management and organization because we've got all of this stuff. And instead of having to have a million wires move around, I recommend taking that content and just putting it into a single list.create node and then generating a dictionary. From there, I can just pass this dictionary along wherever I want and just call for that value as I'm keeps things moving nice and quick. From there, we get to our first custom node, the generate treads. Again, this has been published in the Stairry package inside of Dynamo. So down here, Stairry is the package name. It is up on Package Manager. You can go ahead and download that. It's just got these two nodes, generate treads and generate portal. And as before, we're going to go through and we're going to get our post distances, stair width, floor to floor, all that stuff that we had on that initial sketch piece as our inputs. Come in, do a little bit of design script to sort of work the math to get our individual values, generate our points, create our polycurve, fillet our polycurve based on our sort of tread thickness, generate our individual treads. Again, on both right side and left side. So you can see here we've got true and false. Polycurve fillet only offsets either on the right side or fillets stuff that curves to the right side or the left side. There is no one for both right now. So you have to kind of do that in sequence. From there, I go ahead and create a thickened polycurve. So now instead of having just a straight line, I have kind of the offset line that contains the original line. Turn that into a solid by generating the revolve with the data from the math I did all the way back here. Take all of my edges and all of my faces. From my faces, I'm going to pull the vertices. I'm going to test that vertex to see if every vertex is equal to 0. If all of those are true, then we're going to filter out that face. We take the included faces, so everything other than everything that had a face at where all edges were, points were at 0. And we're going to take those edges and then use a set difference to just filter out the faces that we don't want. This allows us to take just the edges that we want to use, and we use that solid.fillet node for all the edges we want to fillet, our original solid, and our radius, which is 1/4, a quarter of our tread thickness. Output that as our solids from the node. Go ahead and close this, and we'll come back into Dynamo. It has to think in case I made any changes to the custom node, but there you have it. Data in, solids out. I'm going to go ahead and freeze this here. And we'll go ahead and click run just so we can have a look at what that looks like.
As you're doing that, Jacob, the class at AU, the presentation is available, just not a recording, correct?
I believe that is correct. There was no recording. When we originally proposed this, it was a group piece, but Sol had some very good reasons for not attending.
Had a baby.
He had a baby.
Well, my wife had a baby, but I was there.
That's true. That's true. Let's give the credit where the credit's due, right?
Of course.
Yeah. So in any case, as a result, I didn't have time to record that plus my other stuff. So yeah, great news for Sol. Super proud or super happy for him, and totally worth doing it on my own. But it meant we didn't get to record. All right. So anyways, this gets us all of our individual treads, right? This is probably the biggest initial lift. We could take this data and we can move it over into Revit and start to work with it right there, right? Which is pretty cool. But as always, I like Dynamo better than I like Revit, so we're going to stick around in here. I'm going to go ahead and unfreeze this. So from here, I pull my treads and some additional inputs. Post the data from the inputs into this custom node. This is our generate portal node. Now there's two parts to the portal. There's the donut, which is kind of two concentric circles offset that allow this portal to sort of wrap the curve of the outer staircase walls, inner staircase walls. I don't know.
Alley walls, I don't know.
It gets a bit tough, right? So anyways, wall floors, yeah. Wall floors, tread things. So we take our interior post distance stair width, generate some points, use that to basically build a square polycurve by our 4 points, starting here, up, over, and down. From there, we fillet that polycurve. Once again, I'm just using a radius of 1, not bothering to sort of change that. We could have an additional input there if we wanted to.
If you're working in metric, you're going to want to, for sure.
Perhaps, yeah. From there, we're going to close that polycurve with a line so that we can extrude it as a solid, right? That solid is going to become our void form, right? So you can see down here, we take this solid, the extruded polycurve for the void form, and that intersects with our treads, right? We take all of those treads, subtract the difference, and the exterior tread now becomes our one output, and our interior tread becomes another. This allowed me to sort of break stuff up between the inside stair and the outside stair. That's why I chose to do this. Meanwhile, down here, we're going to generate the frame limits. So again, that's taking the exterior post foot distance plus the tread thickness, creating those two circles. Because this is a list, I've got two pieces there. Creating those two circles about a 0.1 unit below the Z, extruding that up 10 units, and then creating a solid that sort of subtracts circle 1 extruded from circle 2. With those two pieces, I can come back here, take our original poly curve that we filleted out, create a thickening curve, extrude that as a solid by our negative stair width, intersect that with our donut shape, and get our portal form. We'll close that. Again, bear with me while Dynamo thinks in case I made any changes to that custom node. And then we're going to go ahead and freeze right after generating the portal so that we can preview this. And I hit run. How am I doing on time? 30 minutes.
Good. Better than usual.
Yeah. I went quick at AU too. So.
Thinking time. You there, David? At AU?
If I don't have somebody to slow me down, I tend to take off at 1,000,000 miles an hour and just go. Great questions from Thomas in the chat. I got problems with solid dot difference with large sets of solids of topography and excavation solids. Is that working for you regularly? Sometimes. And I say it that way because topography in general is difficult because it's really, really big data sets. If possible, I would actually break that out of the Dynamo for Revit engine and work with it in the sandbox context for a couple of reasons. One, it's going to be quicker because it doesn't have Revit slowing it down. And two, I can let that run for like 2 hours while I'm doing my Revit work and just let it utilize another thread on my CPU. But yeah, that actually would be a great AU session if you wanted to present on that, Tom. Wink, wink, nudge, nudge.
Well, on that front, Thomas, like the larger a scale gets, the more difficult it gets with computing in general, not just Dynamo or Revit. So if you're working with extremely large topographical surfaces, you get very weird artifacts starting to happen at the edges.
Yeah, and it's less a question of the geometric scale in terms of the speed and more a question of the number of vertices. So simplifying the topography if you can would be good. But you can see here, I've now put my portal in on that piece. So we can see how all of those stair treads now come down and die on that portal. We've got a nice little overhang. It happens on the inside and the outside. Things are looking good. All right, we're gonna go ahead and unfreeze here and start to talk about our next piece, which is our evaluation. So I get the last item from each one of my lists. And basically what I'm gonna do here is I'm gonna start to sort of check some individual pieces. The two things I wanna evaluate for are the exterior interior opening dimensions and the riser clearance line. And so what I've done is I take geometry A, which is my, my stair tread, let's say this one, and geometry B, which is my next stair tread. And I say, okay, what's the difference between those two pieces? Go ahead and draw a curve by geometry closest point 2, and then shift the indices so that we're always drawing two curves. What's that length, right? Then I have that dimension for what that clearance is. And then I can ask, is A less than 4 inches and is B less than 4 inches? And then 4 divided by 12 converts those inches into decimal feet. Down here, post distance and floor to floor, go ahead and generate the circle, extrude the circle, intersect that. And then again, what we're testing here is the riser clearance. So by taking that circle, extruding it up and intersecting it, I now have kind of a cut line through an individual tread, and we can get the distance there. That curve looks like this. Hopefully we can see it.
Now it's a puzzle.
Yeah, and as I'm changing geometry views, my system's locking up because it doesn't like the amount of stuff I've got going on. I should have restarted before the Zoom.
You live and you learn. Good opportunity for questions if anyone has them. Feel free to put your hand up and speak out loud live, or you can ask in the chat. Otherwise, we play the waiting game.
I am noticing that John Pearson looks like he runs so fast that he kicks up smoke. Or did I read that wrong?
It's accurate.
Superpower. Jacob, you're probably going to have to turn the preview off of the custom node as well.
Yeah, that's a good call.
Also a good call by Patrick. I was wondering the same.
All right, there's my line. Let's see if I can get a view that actually shows it without the stair being in the way. There we go. And I'm going to turn this back on.
Agreed, John. A white screen is stressful when it starts to lock.
All right, so that's the first distance check. The second distance check, which I think is at the same point, generally speaking, we'll see here. I can't remember where I put it. Is trying to check the distance between that tread and that tread, right?
You don't want a wedge zone where you can fall into.
Yeah. Oh, I did it all the way up at the top. So there we have that piece. Now happening here, after I get those the portal done, I went ahead and I built this geometry preview portion so that we could sort of explore the individual parts of the tread. I also put this piece together if I want to pull an individual tread out for people to see. Preview should be on. I should have a geometry color object. Let's zoom extents. There it is. So this is what individual treads look like. And if I go to the last piece, we'll run that, but I'm not going to run it by itself just to keep from locking up. Once I've confirmed everything's code compliant and this is true, we're going to pass this over to this piece. If the test is true, we're going to return geometry. Otherwise, we're going to return null and then pass that into this object identity node just for my own peace of mind to be able to break stuff here as I was building this through, and then a data gate node. This data gate is always going to pass null, even if this passes true data, unless I hit the open button. This comes from generative design, super useful node. And effectively what that does is it's going to make sure I'm only ever passing null through here until I'm ready to move to Revit. And then into this family instance by geometry node, we put our file path for our generic model template. We put the count of number of items prepended by feature stair part space, and then that number as a range 0 to that count. The category, I want to put it in as generic models. The material I want to use, the name of the material, I'm going to use wood-stained. And then the feature stair solids is the subcategory that I want to put this content onto. So I'm going to pull this off to the one side, and then we're going to go ahead and we're going to hit run, right? And now it's going to take a minute. Oh, I forgot to open the gate.
You need to show your family browser first.
Excellent point. Family browser, nothing up my sleeve. Run started, and we're going to see a whole bunch of pinwheeling for a minute while this runs through. There's the first stair tread placed. And so what this is doing is it's actually committing a new transaction into the Revit model for every one of my pieces of solid geometry. If I wanted to push everything over at once, I could just union everything into one solid and then have one solid for my entire stair. But
this is way cooler, as John said. Watching it happen step by step is awesome.
It is awesome. I'm not going to lie about that. I absolutely loved this this sort of hidden feature of that family instance by geometry. And I have exported it as a JPEG by just doing sort of screen capture. Which is pretty cool. So it's going to take a minute. I wish I had thought to center the stair within the view before I hit run, because there's no good way to get this all back.
It's the first session, you know.
Yeah.
A little janky by design. or not.
Yeah. Yeah, very nice cropping.
Good that you're not doing a screen recording of this, because that would be
Yeah.
not the best.
Yeah, and the other thing with this is once it starts, there's no way to stop it, right? It's going to keep going. You can see the portal has now placed. You'll see it better once it finishes.
It's a good opportunity to talk about canceling stuff inside of the context of Dynamo Revit, which is an often asked request. So in this particular case, because you're doing sub-transactions, you could actually have a cancel button that correctly worked, because you'd do a check that the cancel button would inject a cancel command to Revit in between each thread, and it could actually cancel that operation. But if you're trying to push it all at once and it takes 3, 5, 10 minutes, you never get a chance to inject that cancel button. So you can't actually cancel without crashing out of Dynamo. Hence why Dynamo doesn't currently have a cancel button inside of Dynamo in the context of Revit, because it is all in process, which means if you cancel it, you're essentially waiting for that operation to happen, which usually happens at the end of the run of the graph anyway, so it becomes rather useless, or it happens in less useful places.
Yeah. So there are a couple of questions in the chat, which we'll go ahead and get to. My family instance by geometry is missing from Yavid. That's actually from the Spring Nodes package. So I want to go ahead and grab that. All right, so this finished, of course, as I start to get to those questions. So custom node properties, Springs is the package that you're after. All right, so if you go ahead and get Springs, that will have that node. Super useful, definitely worth checking out. It's got a whole bunch of really, really important sort of pieces in there. In particular, family instance by geometry. Like you can't do, you can get by without it, but it's multiple nodes as opposed to one, and multiple transactions in Revit as opposed to one. All right, so there is our stair having been created, and you can see it sort of aligns to my Dynamo geometry preview because we've got those sort of blue outlines. We can start to move through, and because I set the material, we should be seeing the material, but apparently I removed, oh no, my geometry preview is on top. That's the issue. I'm going to go ahead and turn off the preview on this. And that, whoop, did not mean to freeze that, I meant to turn off the preview. It's still not rendering right. Well, I'm not sure what happened to my actual pieces, but conveniently, we did grab a couple different views. So one of the cool things with this is because it's all sort of driven by nodes, we can very quickly sort of do a bunch of different studies. So this is playing with different input values to sort of see what works, what doesn't. You can go a step further than there and actually just sort of push it over into generative design. This was the setting that I liked the best from that list of options. We went ahead and we did the open zoom extent, and hey, John, here's your animated GIF, and it should actually be centered this time, which is pretty nice. And this is in the same speed, so we won't watch that happen kind of all over again. But when the material textures are actually present, it does bring that texturing over, and you get some really interesting views of this super
cookies.
Yeah, it makes me think of sort of a giant pizza-shaped cookie, and we're chopping it up and handing out pizza cookie parts and all sorts of other really cool views. All right, Thomas had a question, the code block with test question, can I explain the formatting? Absolutely. All right, so back here, this one. So what this is, I could actually get rid of that space. Design script is very forgiving with formatting, unlike some other languages like Python. I can't put a carriage return midway through, but I can in design script, which is kind of nice. What this is by saying variable one, my test, question mark, is saying this is now an if statement. I'm going to test, is test true? If it's true, return this. Colon, if it's false, return that. Right? And that's how the design script works. In some cases, I will do, oftentimes when I'm writing an if statement like that, I will just offset it to make it easier when I'm looking through larger code blocks. Like you can imagine something like, oh, I don't know, the code block that I had in here at the initial beginning, where there was a whole bunch of different stuff going on for the math or the math that's happening here. Playing with my formatting like that makes it easier for me to find stuff that I might be looking for. So hopefully that answers that.
Jacob, there's a question from Menno. I use this node a lot, so the Springs node, but is there a way to create a family with different type?
So you can. There's not an easy node for it. The one thing to that is there's a whole lot of value to it, but not necessarily in the context of this. So what I mean by that is I could have set a custom node up that would have done some Revit API work and allowed me to vary the heights of the treads and the rotation of the treads and all this other stuff. And that coding that node would have taken probably a couple days to get it sort of scalable and workable. Whereas really, if I'm sending over the right geometry for the one type that I'm working with my right variables, I'm not really going to need to flex it. If you do need to build flexing geometry, I recommend just do it in the family editor and then use Dynamo to sort of do your flexing for the time being. All right, other questions?
Jacob, maybe there's a question about like nested if statements. You could probably just whip one up on the fly, because me typing it into the chat doesn't work so good.
Yes. All right. So where is that?
You can just make one. It's just like,
yeah,
you test something. If it's true, return something. Otherwise, do another test. If it's true, return something. Otherwise, do another test. Ad infinitum until you have a default value at the tail.
Cool. All right. So I'm going to not run it in that Dynamo because I don't want to lock up Revit, because Revit's gonna try and recommit all those transactions. So we'll leave this open for now so we can refer back to it, but I'm spinning up a Dynamo sandbox. But effectively, the language, and I'm gonna type it here, but then move it over, is test1 question. Let's say if test 1 is true, we want to return the letter A. We can just type letter A, or we could define variable A, or just first true. After that, we can say test 2 question. Second true. After that, test 3. And this is where sort of doing those offsets helps, because you can imagine if I did this all in one line, that gets a lot more confusing.
Harder to read. Yeah.
Right.
Legibility thing.
This bit of legibility definitely helps. And then after test 3, third true, else all false. Right. Looks like that. And I think I've got a sorry, test 3 question. There we go. All right. So taking all of that and popping into the Dynamo sandbox instance that opened on my other screen, new Boolean node, call this test 1. A, test 2, test 3, B, let's see, second true, first true, and then we need all false. So this currently returns D because everything's false, but if I toggle any one of these, we get the particular value that we're after. Now, note, if I toggle both, it's just going to return the first true statement because it's going to say, hey, I found this to be true. So I'm going to stop looking and just return the second true. This can make them a little bit faster than some other methods out there that might have to calculate both ends. Useful to know. We actually had a Dynamo Forum post about that yesterday, which had some pretty good back and forth on it as well. So hopefully that answered that question.
We probably have time for 1 or 2 more questions if you want. They don't have to be about what you saw today, because that's hefty to think about and digest, potentially. So any other questions, fire them away in the chat. Otherwise, we can run through our closing sequence. I will say these kind of if statements in design script are really, really, really useful to start thinking about if you don't use them yet, because they're really fast to put in comparative to a sequence of different nodes. And so you can do funky things with them, like Jacob has just shown, with nested if statements.
There's a good question in there from Yavid. Any tips for structural design in Dynamo? I actually have another demo. I think we might have actually covered it in one of the office hours. I've been giving this particular demo since like 2018. So it's a while, or 2017 maybe, I don't know. It's a while back, but you can start to sort of automate the framing of pretty complex members using Dynamo. Point by coordinates, XYZ 0.10. Sorry, number 10, step by 10, math.random list 10 times 10 plus 10. There we go. So this is going to give me some random points on my X and Z. NURBS curve by control points. There we go. So that's a pretty elaborate shape. What if I had 2 of those pretty elaborate shapes, but Y was set to always be 10 units away? Whoop. And let's say you needed to figure out the rafters that framed up my loft. Great feature monocle right here from John Pearson. Thank you, John. Oh, I did a solid. I wanted to surface by loft. Here we go. All right, so let's say you had to figure out the rafters for all of those individual pieces, right? How would you go about locating each one of those rafters? Quite a lot to do there, and it's pretty difficult. What I would do, surface curve.length, take the length of each one of those curves. My max spacing, let's say, is 48 inches. Sorry, 4 feet. We're going to say A divided by B. This is going to tell me how many of those points I need. Maximum item. I don't really love that shape, so we're going to try this once more. Whoop. Did not see myself hit that. Yeah, that's a little bit more fun. So we can get the maximum item, ceiling. This is how many rafters I'm going to need. And these numbers are pretty much the same, but you can imagine if these curved in plan, we'd have an even more complex shape. With 24 rafters, I can do curved point at parameter from 0 to 1, that many points for both of my curves. Set this to use level 1. And notice that I set the wrong list to use level 1. I actually wanted this one. By best fit 3 points.
It needs 3 points, not 2.
There we go. So there's the straight curves at the minimum spacing all the way through that complex piece. That would take a lot longer than that to do in Revit, right? Because there's great tools for doing other pieces, but not necessarily for that kind of geometry for structural beam systems, right?
One thing to be careful about with those, like NURBS curves calculate distances slightly differently, which is why you'll notice that the gap between them is not consistent. If you were to use a poly curve instead of a NURBS curve, which Jacob's probably going to demonstrate now, you should actually get more equal distances.
Yeah, I would actually use best bet would be curve point at equal segment length rather than the other piece. Now, the drawback with this is it doesn't give you your 2 endpoints, so you wind up having to append, but you know, it works.
Different ways to do things.
Yeah.
So Thomas is asking a question just before we have to wrap up. Like, is there a way to select geometry in the background and find the node that creates that geometry? Yes. You should be able to just go into the background preview and select something, and it should highlight the node in question. There you go.
Right. So
as
if I go
demonstrated.
really big and pick a geometry, so I picked this surface, it can be tough to grab the right piece, but and sometimes when you select multiple things, you get things on top of things, but it just doesn't want to let me pick my points. We'll just go with the surface. Now it doesn't want to let me pick my surface either. Come on. Oh, here we go.
You're in node view. Yeah.
All right, so now in node view, instead of geometry view, zoom extents, and it's going to bring me right to that piece.
I believe Control-0 was the keyboard shortcut for zoom extents. If not,
Look at the applause there. Nice build up, Jacob.
It might be. It appears I actually have a code block out in the middle of Oklahoma. So yeah, Control-0 is zoom extents, and it does zoom to the individual pieces too. Yeah, so if I wanted to pick points, we could just hide the curve. Let's see if it lets me pick. Yeah, it's grabbing both because they're on top of each other.
Yeah, points are kind of infinitesimal size-wise, so it gets a little trickier with those, but with bigger geometrical objects, that gets a little easier.
There it is. So,
all right, I think that's us with 3 or 4 minutes left. Okay, so next Dynamo session. So Jacob and I have mapped out the sessions for this year. I think we have another, 15 sessions or something crazy coming up this year. Coming up on 9th of February, we have Rising to the Occasion, where we actually continue this series on this on Stairs and talk about doing more things with it in Revit. And then we talk about writing the Stairry story, which is documenting these stairs inside of Revit. So it's a 3-part series in many ways. Then we're doing on the 9th of March, packages of note. So some really cool packages that exist out there, partly from internal with Autodesk, partly from the customer base that you should consider using with an unknown special guest because we haven't found one yet. And then many more awesome things to come.
All right, my part.
Yeah.
We're going to wrap up with some resources for the community here. Let me just paste them for you. The recording will go into the Dynamo Office Hours YouTube playlist that I pasted earlier. There's many different things. There's the community forums, of course, the Dynamo BIM. I should give you that too while I'm thinking of it. The Dynamo Blog. A lot of resources in the community. So make use of those. We hope to see you back. We'll be adding more of these Dynamo Office Hours to the calendar very soon. I know that Jacob and Saul are working on more of the details. But anyway, always, if you want to reach out directly to me, please feel free to, and always looking forward to seeing you in the community conversations. So stay connected to the communication or the community. Gosh, I'm stumbling all over today, guys.
Doing fine.
New year,
Yeah.
new year.
Exactly. One other thing to note, which I forgot to say, is you'll notice this year is going to be more focused around workflows. So previously we were focused around concepts in the first year. The second year was focused around hosts and host integrations. And this year we're going to focus a lot on how to actually do more coal-face things in the AEC industry. In this case, we're starting with building a funky stair and going through that whole 3-part series. Later in the year, we'll be working through other awesome things too.
That was awesome. Stairs were beautiful. I can't believe that's Jacob's house.
All right. Well, thanks everybody. It was a blast, and looking forward to showing you guys some more cool stair stuff next week.
See you in 2 weeks.
Thanks,
Oh, yeah,
everyone.
2 weeks.
2 weeks.
Bye.
Catch you later.